start recording, and I'm going to share my screen. All right, does everybody see that?
Yes.
Yeah, we can see it.
Great.
Yep.
Yeah. All right, so get started. Oh, let me post these notes in the chat if you guys want to follow along or find these references later. And I haven't added these links to OpenLab yet. I need to do that. I'll do that later. Anyway, we're going to start talking about level design. Oops. There's a bunch of different concepts that we're going to go over, and there's basically like 3 different parts. There's a little bit of like history and technical terminology. There's a little bit about different like approaches, and then different principles. So we'll go through those. So there's a few different kind of concepts that we're going to tackle. And mainly what I want you guys to take away from this is just start thinking about how your level looks and what you want it to do. So there's no like real hard and fast rules with this stuff. A lot of like creativity when it comes to level design is like, you know, just like following your instincts and just like throwing stuff on the page and then seeing how it looks. So I'm going to give a bunch of examples and, you know, sort of guiding principles and stuff like that. But there really, you know, there aren't really any rules, you know, as far as this stuff goes that can't be kind of flexible or, you know, played with. So first we'll just talk a little bit about what a level is, and then we'll look at some different tools. So what is a level? We talk about levels a lot. You know, I think everybody has sort of like a working understanding of what a level is. It probably seems very like obvious to say like, what is a level? But one thing that I want to point out is that in video games, levels tend to be defined by a space. That's not true in every video game, but in most of them, a level is usually defined spatially. So the boundaries of what the player can sort of navigate into or out of. Everything else that happens in the level is kind of like defined by that space, and we'll kind of like talk about different ways of using space. But what I want to, you know, emphasize is just how much of a spatial medium video games really are, and that we kind of use space to show the player what's possible and kind of lead them in different directions throughout the level. In some games like Pac-Man, okay, so here's a Pac-Man level, and actually this is every Pac-Man level, at least for the original arcade game. The differences between the levels in Pac-Man are not like the layouts or you know, the basic mechanics, but rather sort of the increasing difficulty as you go through the game. So with Pac-Man, you know, you can see the entire boundaries of the level. There's some things that you wouldn't necessarily know until you experience them. For example, if you guys have played Pac-Man before, you know that these like, these like little gates here, or whatever you want to call them, like goes, you know, kind of loops around the map. You might infer that from looking at the map, but you don't, it doesn't necessarily tell you that from the beginning. But pretty much everything else that you need to know about this map is basically right there. You can tell that there's a bunch of collectible items that you need to achieve. There's some bigger items on the map that, you know, even if you don't know what they're going to do, because they are so much bigger than everything else, it indicates that those are more valuable items. You can see other information like the score, the number of Pac-Mans that you have to play the level, as well as the enemies and where they're going to come from. A lot of the other information about this level in Pac-Man comes through the gameplay. So just looking at it, we get a bunch of information, but we have to actually play the game to get the rest of the information, like how the ghosts move and what the different power-ups do and stuff like that. But we can see all of this information pretty much right from the beginning. In a lot of games, that's not really what you would see. The space is not completely visible from the beginning. You have to explore it. And so many levels, probably most levels in in video games, you have to actually kind of explore the boundaries of the space. They aren't necessarily presented to you right at the beginning. So let's continue. Whoops. So most games consist of a sequence of levels. There's a little bit of flexibility as far as like what that means. With the example of Pac-Man, all the levels are actually the same, but the difficulty changes, and the speed of the ghost changes, and other things change to make the game more difficult as you continue. But most games consist of a sequence of levels, and typically each level is sort of a section of a larger space or world. Especially these days, most games have some sort of map that's accessible to the player where they can see like how their particular level or what level they're on fits into the larger sort of spatial or world of the game. Typically, a player has to defeat a challenge or solve a puzzle or perform some sort of feat to get from one level to the next. So usually the progress of a level is sort of defined with an ending that leads to the next level. This is pretty obvious, but just thinking about it from the sort of bare bones of how these things work. And as you play a game, levels tend to increase in difficulty. That increase in difficulty is usually offset by the player sort of like increased knowledge of how the game works and increased mastery of the mechanics of the game. And so those two things kind of in opposition create the overall sort of progress or balance or pacing or whatever you want to call it for a game. So those are some really basic, ideas about how levels work. Moving into kind of more the technical aspect of what a level is, levels are really just collections of data. So they're really just like a series or a collection of references to the components that make up a game. So if you have a game that involves 2D art or 3D models or animations or other types of graphics, as well as like audio, scripts, all these different things, maps, the level is really just like a piece of data that kind of tells the game engine where to put everything, all of the different assets onto the screen that's displaying this information. So you can think of a level as kind of like a recipe for the game engine to say, this tree goes here, this mountain goes over here, the player starts here, the enemies start over here. The gameplay kind of like obviously results from there, but the level basically just tells the game engine how to create the world that the player sees. This image is actually what, if you open mainscene.tscn, our level or our resource from Godot. If you look at that, that's what it looks like when you open it in a text editor. And if you wanted to, you could create an entire level if you were, if you really had a very good working understanding of how the code worked. You could create an entire level just by writing in the text editor. Obviously, these days we use very sophisticated game engines like Godot or Unity or Unreal or whatever it is that allow us to do this visually. But in theory, you could just write all of this stuff out on a text editor, and if you did it correctly, it would work. So this is the beginning of the file for the main scene. You can see that the first thing it has is a bunch of references to all the scenes that are contained within that main scene, as well as references to the artwork, to the audio files. You can see there's a reference to the tile set that we use to create the tiles. This is another page a little bit farther down in the same document. You can see this is the platforms, and you can see if you look at these numbers, if you look closely at these, you'll start to understand what's actually happening. Like these numbers all represent positions, and then the number of the sprite, and then the number of the tile within the sprite, and that's how the computer learns how to place all the images on the screen. So we do it, with the mouse. We put each tile where we want it to go, and then Godot kind of like wraps all that up into a nice little level data file. And so when we build our game and it gets played on a different computer, that computer knows where to put all the images and when to play the audio and all of that different stuff. So you can kind of read through this file and actually start to see stuff that you probably recognize for the game. Like here we can see this node name equals metrics. So that's where we are displaying the metrics, the UI. You can see the anchor that's set up. So it's really all the stuff that we're doing is just getting dumped into this big file that then gets exported with the game. So it's a little bit about Godot specifically. Historically, the level design tools went from basically people writing in documents and placing things individually just by their numbers to becoming more and more sophisticated tools, either internally for a game studio or as commercial products like Game Maker or Godot or whatever else. This is a map generation or creation tool called Tide. And it looks pretty familiar to us. We can see the kind of sprite sheet that's being used down here, and then you can see how you place in the tiles. This is a pretty old open source project that's just used for generating maps, and it saves all the data, and then you can put that into different types of game engines. So this is relatively like an earlier version of something that we might do with Godot, just using a map editor. So we can see a little bit of the progress that these tools have made over the years. This is kind of like what I've already said, so let's keep going. So another thing that happened with video game design tools, starting with ZZT, which is a game from the 80s, it was the first game to allow users to create their own levels. And this has led to like a really cool aspect of video game culture where a lot of game developers and studios will actually release the like software that they use to build the games or level designers. So Doom was an early game that did this, allowed users to create maps. Half-Life also has a ton of user-generated maps. And that's a really cool aspect of what's happened with game development, is that by giving users the ability to use the tools that are created to design like big name games that people are familiar with, that's led to lots of cool user-generated levels and communities around those levels and creating levels, and also full-on commercial games that are made out of mods and stuff like that. So ZZT was kind of the first game to release their editing tools to users, and that created a really cool sort of precedent for other game developers and studios doing the same thing. There's an article kind of about the history of ZZT and their decision to do that, and the communities that came up around that. And as I mentioned, there's a lot of other games that do this. Doom and Half-Life are probably the most notable ones, but there's a ton of other games that make their tools open to users. This is an image from the Stanley Parable. I'm sure a lot of you guys have played that game. It's a mod from the Half-Life source engine, and it's an interesting game. It's more of a sort of like philosophical thesis about games than it is like a game itself, but it has a lot of interesting qualities to it, and it is like a full commercial game that the Half-Life people sort of like allowed it to become its own commercial entity. So that's a good example. There's a lot of other examples of mods that have turned into their own games. One other type of level design that I'll just mention briefly is procedural generation. If you guys have played Binding of Isaac, which I know some of you guys have, you'll recognize this is kind of like a tile set of how a map is generated in Binding of Isaac. And Binding of Isaac is a roguelike. We talked a little bit about this in an earlier lecture, roguelikes and Rogue, the original game that had procedural generation. So, to recap from before, basically Rogue was this really early game in the 80s that was a dungeon crawler. And because like they were just distributing their game across networks, early internet networks, they needed to make it really small so that it wouldn't take forever to download. And so instead of like having a lot of levels that were predefined with lots of files that have each like little part of the game specifically designed in one place or another, instead they basically wrote a program that would generate levels from scratch. And that would, that way it was much smaller. They could distribute that code, and then the user's computer would actually build the levels instead of the designer doing it themselves. So this is just, this is another style of design. Instead of like visually placing everything in the scene, you write some code that kind of does it in different ways. So it's, it's another legitimate way of designing scenes. I actually typically, that's how I tend to design games that I'm working on. I could show you guys quickly a map generation tool that I've been working on. I think I have a copy of it in my P5 library over here. Yeah, so you guys can see that. So this is basically like a hex map generation with a maze built into it. So it generates a hex map, and then depending on different parameters, you can see that it builds a maze around the hexes. So it kind of creates a level. So I don't have to, decide each time exactly what the map will look like, but this will generate one for me. I used a similar one. I think I showed you guys this game earlier in the year when I was like showing some stuff that I work on, but I can show you the map generation that I made for that. This is just a visualization of that map. It's pretty similar to how Rogue generates maps actually. It's a slightly different algorithm, but you can see every time I click, it generates a completely new map based on different parameters, like how many rooms I want, how easy it is to navigate in between the rooms, and different stuff like that. So I've created some tools that are really based on other people's concepts of how to generate different maps and things like that to help with my own level design process. So anyway, those are just a couple examples of things that I use. Okay, so let's get into some level design principles. Any questions so far?
Yeah, Professor, I was just wondering how using P5 can be practical for level design. Is it practical?
Oh, yeah. So it it actually is for me, it's a really good tool for design. I think there's versions of this tool for every developer, but I have mostly professionally done web development, and so I'm much faster writing JavaScript than I am any other language. And so for me, P5 is like I can open up, a P5 window online and just start writing and immediately get some graphics. And so that makes it a lot easier for me to like test things out and not spend a whole lot of time, like downloading some software, writing a bunch of code, see what it looks like, and then do that. I can test some stuff in P5. And then I think kind of what you're asking is like, let me open that map generator again. So once I had this to generate maps for me, P5 is just like one way of visualizing things, but the code works exactly the same. So then if you look at the game itself, which hopefully doesn't have any errors, I haven't opened this in a while. So this is a game itself. It's obviously using a different rendering engine that I wrote, but you can see I have a little shortcut. I can actually see the map, and you can see it's the same thing. And that map actually maps exactly to what you see on the screen. Like you can see that blue dot moving around. And so this is basically like a way for me to visualize using P5 because it's a lot faster to write what's happening on the screen in a smaller setting. Whereas like what's actually happening in the game is this like much more complicated rendering engine that I wrote, and I wouldn't want to have to like spend a ton of time rewriting stuff just to make like this mini map or whatever. So it kind of allows me to like test stuff and sort of like figure things out without in a quick way that I can then really easily implement into something else. So if you were working at like a game studio, they're probably not going to publish their game using P5, or they might. It's a pretty good language for games, but most likely they're going to have something else that they publish it with. But if you're a designer and you just want to show how something would work really quickly as a proof of concept, Languages like P5 are really useful for that. Does that kind of answer the question?
Yeah, thank you.
Cool. Okay, so these are some level design principles. Again, these are not like rules. It's not like doing math where there's like a right answer. This is just like a way of kind of helping you understand what you see in games that you're playing and how you might apply that to your own game. Something that happens a lot as an artist or a designer is that you start to do something and you realize eventually down the line what you're doing is actually this like really basic principle. And so learning the principles first is a good way of like being able to reflect on what you're doing as you're doing it. There's still always going to be like a discovery process through your art practice or your design practice. Learning these principles isn't going to turn you into a great level designer overnight. But if you understand the principles, or you kind of like know what they are, then you'll start to see them in games, and you'll start to understand how they relate to each other. So we'll just go through a few of them. This isn't like an exhaustive list or anything like that, but I think it covers a lot of the basics. So one of the things, there's different terms for this, but I like the term guidance. It's very simple. It's basically like a guide. Like if you have a tour guide, they're going to take you through a city or wherever you are and explain to you like the relevant history and where you can find a place to eat and all those things. So you can think of guidance as that. It's sort of guiding the player through the game. There's a few things that we have to introduce in a video game to make it make sense. And really good games do this very quickly. Really complex games may have a harder time doing this. So they might have like tutorials or explicit instructions. Simpler games can just do it like with visual cues, like, here's a big bright light, just walk towards that, or, here's a big sound or whatever. So you'll see this happen in different ways in different games, but it is the same thing, regardless of whether it's like an explicit tutorial or just a strategically placed set of things that you see in the game. So the first thing that we have to do with guidance is introduce the mechanics of the game. You can kind of see this is like a mock-up of like a Mario game, and if you reduce it to these basic elements, you can kind of see green things will block you, orange things are rewards, red things are going to hurt you, green things are power-ups. Like there's these few basic essential elements that all get introduced in Mario in the very first scene. And most games will do some sort of version of that. It's also really important to make the goal of the game explicit very quickly. The like current goal of the game should always be very clear to the player, whether it's just to get to the end of the level or to find a key or to do whatever it is that they're doing in that specific scene. But there should always be a goal in mind. You can probably think of games where the goal is a bit more mysterious, where you have to figure out what's going on in the game. If that's the case, then there has to be something else that's compelling the player to go forward. Like there's a really cool story that they want to keep hearing, or there's some really beautiful, mountain that they want to explore or something like that. But typically you need a very clear goal, and the player can understand that goal. For us, we're working on 2D platformer games. So the goal is pretty obvious usually, that you just have to, get from one place to the other. But you can play with that a little bit by adding dimensionality as far as, going up or going down, or, going back and forth. But the player should always know like what direction they want to go in and why. We also have to use guidance to introduce obstacles and rewards. And then obstacles and rewards start to lead us into the gameplay, the challenges, those other things. So after we understand the basic mechanics, then the game designer will throw in some obstacles, some challenges to, make us have to use those mechanics to get through the game. And that's really where like the fun of games comes from, is the sort of like fun of defeating challenges and using the game logic and the game mechanics to achieve and to get past those challenges. Rewards are used more to kind of like reinforce the goals of the game, but also lead you towards different places. In Sonic is a really good example of basically you just have a whole bunch of rings that, you want to collect, so you're going to try to collect them. And Sonic, this is the Green Hill Zone level. You know, it uses the rings in a lot of really creative ways. It asks you to go in different directions, and there are points where you have to decide if it's worth it to get some rings versus another. You know, that'll come up a little bit more in a minute, but we use rewards to kind of like direct the player through the level. So the perfect player principle, this is an idea that I kind of like thinking about. This is the idea that a player, like a very talented video game player, sometimes you might think of like a speed runner, but it's not quite a speed runner. It's not necessarily about finishing the game in the fastest time, but the sort of the most efficiently. But this idea is that a player who knows nothing about your game or how it works could complete the game on a first playthrough without any prior knowledge of what's going on. And so that's kind of an interesting principle to think about with the game, where it's like, you know, I think Saiban Action is a game that we all played, and one of the reasons it's interesting is because it really sort of violates this principle. There's a lot of sort of like hidden gotchas and things that you would never be able to predict. So obviously, you know, this principle fails in that case, but in most games that aren't you know, engaging in that that style, you should be able to, you know, beat the game, assuming that you are, you know, the perfect player, that you don't make mistakes and that you do everything that's asked for you to do. You should be able to beat the game on the first try. So that's an interesting thing to think about when you're designing levels, because you don't want to create systems where the player has to die a bunch of times in order to figure out the game, unless that's something that is built into it. There are games where that's just part of the game. Outer Wilds, which, you know, I've been playing a lot, is a good example of that, where that's actually part of the core mechanic. Sorry, it's small spoiler alert there. Anyway, this is from the game N. Maybe some of you guys have played this, but it's like a really challenging 2D platformer. And I think of this game a lot when I think about the idea of the perfect player principle, because the game does lay out the whole map for you. It lays out everything that you would need to do to get from one place to the next, but it's like extremely hard and requires extreme precision in play. So I think this is a good example. They also have really good levels and level design. So if you haven't played N, I would check that out. It's fun. Another thing that we want to think about is unique level design. This is just the idea that each level is different. So a game gets pretty boring if you're just kind of doing basically the same thing, one level after the next, without any, you know, change. And unless you're really motivated to get like a high score, like in early arcade games, you're probably not going to, you know, find a game that has the same level over and over again very interesting. So one way of thinking about a unique level design is that a really good level, any player who's played the game should be able to say to another player, oh, like, remember the level with this, or remember this level, and they'll immediately know what they're talking about, because each one of the levels is significantly different enough so that something would stand out. So that's kind of one way I like to think about it. An example here is from the game Psychonauts. I don't know, maybe you guys have played this. This is kind of a earlier game, but it's one of my favorites because I think it's just like really unique and interesting. I would definitely check it out on like an emulator, or just like watch videos of it if you're interested. But the idea behind Psychonauts is that you can. I'm getting a little echo. I'm gonna have to mute. Okay. Sorry. So the idea behind Psychonauts is that you're this like adventurer, and there's this like technology that allows you to basically go inside people's minds and like explore their psyche. And so each of the different levels is like basically the mind of a different person in the game, and you're kind of like running around their psyche and trying to fight off ghosts and do different stuff. And it's a really creative approach to a game to begin with. But then there's this level, the Milkman conspiracy, which is really famous. That's this kind of like crazy conspiracy theorist. And so everything about his world sort of turns things upside down. Like gravity keeps changing and all this other crazy stuff happens that are all kind of like representations of the psychology of this character. So it's a really cool example of like a very creative level that anybody who's played that game would immediately be able to say, oh, like, remember the Milkman conspiracy, and you would know exactly what they were talking about. So that's a good example of that concept. Okay, so the last one is pacing. This is one that I am less like, one that I don't really think about quite as much, but is probably more relevant for arcade games or fast challenging games. But basically the idea that, you know, a level shouldn't be too short and it shouldn't be too long and it shouldn't ask you to do too many boring or repetitive tasks. This one I wouldn't worry about as much, but the example I use here is the water temple, which I think is an interesting example. I'm sure a lot of you guys have played this level and played this Ocarina of Time game, and probably have heard with this particular level that the game designers actually apologized for how repetitive and arduous it was. But some people really love this level because it's so complex and because you know, it has this really intricate design. And so I think that's an interesting thing to think about with pacing, where they did, you know, ultimately feel like, you know, it was too arduous. The pacing, you know, requiring the player to move the water up and down over and over again was like, you know, not good pacing essentially. But some people really love the level as well. So yeah, Travis hates it. So I think it's a very controversial level. I don't think anybody who really likes it doesn't recognize how arduous it is, but it is, you know, kind of interesting from this perspective. Okay, so we're going to get into some level design techniques. Again, not an exhaustive list, but just a example of a few different things that you can do within a level. Any questions before we get into that? Okay. If you do have questions, feel free to speak up. Okay. So again, not an exhaustive list, just a few different techniques that you'll notice in a lot of different levels. So signposting, this is like, you know, similar to the principle of guidance. Signposting is the use of literal instructions, visual or audio cues, narrative, character dialogue, any other signals that basically progress the player through the level. Really simple example here is Link looking at a literal sign telling the player to go in a literal direction. But it's important to know that not all signposting is just signs. Sometimes it's a glowing light that you move towards. Sometimes it's a path. Sometimes it's audio cues in different directions. But basically, any time that we're just saying to the player, go over here, that's not an obstacle or a reward. That's signposting. Gating is another concept you guys are probably familiar with. It's just the idea of restricting areas and then asking the player to find either a key or some figurative version of a key to open the door. And that's a good way of basically dividing up space. So the player sees that there's a door that they want to go into. If it's locked, that will indicate to the player that's somewhere that I want to go. And so then they have to explore other parts of the space in order to find that key. So that's a nice way of saying, instead of like, okay, you just have to go from point A to point B, actually you got to look around everywhere around here so that you can get to point B. So gating is a really common thing used in a lot of games. The ice key is probably, kind of an ironic example of gating where if you guys have played Banjo-Kazooie, you might know about the ice key, which was like, this big mystery for a long time. And you can look into that here, but, just kind of like a sort of example of this like idea of like, you have to do everything to find this key, or exploring everything in order to find this key to unlock the next part of the game. Risk versus reward is harder to do in a game, but it is like something that can make games really fun. It's basically the idea where the player has to weigh the risk of, exposing themselves to danger or failing a puzzle against the potential reward. And this is basically like everything in games is like, even something as simple as doing a little puzzle where, the option is you get something, or if if you get the puzzle wrong, then you lock that part of the game forever or something like that. So this is used all the time in games in a lot of different places. Blood Gulch, if you guys played Halo at any point, you probably remember this scene, which is a really good example of risk versus reward, where in order to play the game, in order to win, you have to expose yourself to danger. And so you're constantly balancing risk versus reward as you're playing the game, as you're creating a strategy. You have to kind of make these difficult decisions, and a good game will kind of like make it hard to make those decisions, so that that's sort of the fun or the challenge for the players, trying to figure out what the best strategy or what the best approach would be. Safe zone is kind of related. This is a technique where you kind of give the player some areas that are clearly safe or obscured from danger, and then they can move into those areas and move out of them to kind of have some control over what's happening in the level. Classic example of this is Space Invaders. As long as you're behind those little green things, you won't get hit by the aliens. But at the same time, if you stay behind the green things, you aren't able to attack the aliens. So there's this safe zone principle where you can hide from danger, but then you have to leave as well. That's another very common technique used. Foreshadowing is used in a lot of games, where you're kind of revealing some future challenge or some future clue to a player. For this one, I actually included something from Outer Wilds, which is a really, I've been talking about it a bit this semester. It's a really good game, so I recommend you guys play it if you're interested. I won't really spoil everything, but this is like the first thing that you see when you start the game. And there's actually a lot of information within this view that kind of reveals stuff later. And so if you're paying attention from the beginning, you see a lot of stuff. It doesn't necessarily tell you the answer, but it kind of like foreshadows what you're going to be looking for later on in the game. Last two ones are branching and then bottlenecking, which kind of go together. So branching is giving the player multiple ways to beat a game. So that can be very simple. Like if you're making a platformer like we are, you could have one platform up high and one platform down low, and the player has the option to go to either one. And that can play into risk versus reward as well, because one platform might have a challenge and the other might have a different challenge, or whatever it is. But that's basically the idea of branching, is you have multiple options to choose. It can also be very complex, like in games where you might choose to be on one team or faction versus another. So once you kind of go down one branch, you kind of cut off other possibilities in the game. So it can be very simple or very complex. And branching is typically used together with bottlenecking. So once you do go out on a branch, we do eventually have to come back into the main story or the main goal of the game. This is a good visualization and also a really good article about, this is more about like narrative fiction decisions, but I think it applies to game design as well, where you see where, if you're the player, you start here and you have a bunch of options, but then those options all bottleneck here. So, you kind of like have to make these choices, and then you see where they end up. And so this is very typical design for like a video game, where you might have like a few basic options, but then you kind of lead here, then your options get more complex. Then you have these like completely separate branches, but they all eventually bottleneck back to here. And then depending on various choices that you made along the way, you might have like some good ending, or you might have some bad ending. And so that adds a lot of sort of like drama or stakes to the decisions that you make. Like you might not know, it might be hinted that, if I make this decision here, that eventually leads to me having a bad ending or a good ending or whatever. So that can be kind of more complex, or it can be simple. It can literally just be different platforms in the level that you choose to jump on. Layering, I think this is the last one. Layering is the idea that you basically introduce one mechanic and then you introduce another mechanic and then you put them together. If you watch that video on Mega Man that I sent out recently to the Discord, that has a lot of good examples of all of these principles, really. But he talks about that in Mega Man, where you get the first mechanic, which is jumping, and then you get the second mechanic, which is shooting, and then you're pretty quickly asked to combine those mechanics together to defeat different challenges. So, that's basically just having more than one mechanic that you have to kind of navigate at once. So that's the idea of layering. I think those are all of my principles. Again, not exhaustive, but just a few basic things to think about when you're designing a level. Obviously, I have a lot of resources for this, which I think are all really good. I'll just talk about each one quickly. Any questions before I do that? Okay. So I have a bunch of different resources here that will kind of go into more depth about level design. I'll just show them real quick because I do think a lot of these are really good and you guys should check them out. Not required. There's, it's not homework, but I think you guys will find it interesting. Level design lessons. This is just a PDF by Anna Anthropy, who I think is a really good designer, very well-regarded designer. And this is like some really basic stuff, but really, really well written. And also talks about platform games, so that's useful for us. This is a GDC talk by a designer named Robert Yang, who I think teaches at the NYU Game Center and makes games as well. It's a really, really good talk, and it goes into a lot more depth beyond just like the sort of like basics of level design. He talks about like architecture and history and politics and all this stuff. It's really, really good. There's a couple other videos here that I think have like interesting components. This is a devlog where this developer is kind of, I have a ad. He's making like a platformer, and so he has this like really long, like very, he's got a lot of these where he's talking about all the different mechanics that he's using. So it's pretty interesting to follow. This guy has this level design philosophy video. He's talking about this, his design. So there's some interesting ideas in there. Level design patterns in 2D games. This is a really good one just in terms of like basic concepts. Like it goes through all of these different like kind of like terms. A lot of these we've talked about today. He talks about other basic principles. There's a lot of good stuff in here, a lot of good examples. And then the last two of these are like big, just kind of like collections of level design articles. So this is just like the knowledge base on leveldesign.org. There's just like a million articles here. One thing that is frustrating is a lot of the links are not working anymore, but there's a lot of good stuff on here. If you have like specific like, ideas and you want to explore what other people have done, this is a good place for that. Also World of Level Design has just like tons of like tutorials, all this different stuff that you can look through. So those are a few good resources. One sort of short article on procedural generation, but just to give some more basic background on what that is and how it works, if you guys are interested in that. And yeah, that's pretty much it. So I'm going to stop recording now.